This is the moment that changed everything. This is the most important moment in the history of the human race. It is when we left footprints on another world for the first time, but by no means the last. I'm Damon 𝐒𝐭𝐞𝐩, and this is Astronomical. This is the Apollo 11 landing site. This scene right here was taken moments after Buzz Aldrin joined Neil Armstrong on the surface of the moon. These two men etched their names into history by becoming the first two humans to set foot on another world. But there was a third astronaut aboard this mission. His name was Michael Collins. He's become known as the forgotten astronaut, and yet his role was equally instrumental. Whilst Neil and Buzz were doing the legwork on the surface of the moon, he was in orbit, awaiting their return. And during every orbit, he would spend 48 minutes on the far side of the moon, unable to communicate with not only everyone back on Earth, but also Neil and Buzz. He was the loneliest man in the universe for those brief periods. In fact, when Neil and Buzz actually landed on the surface of the moon, he was unable to communicate with anyone. He was not aware that they had been successful, which would have been a major concern. Around his neck, he carried 18 contingency plans. These were necessary in case the mission would fail, in case Neil and Buzz wouldn't be able to return from the surface. This brought him a great deal of stress. In fact, President Richard Nixon even prepared a speech to give in case Neil and Buzz didn't make it back. The mission to go to the moon was unprecedented. It had never been attempted before. The moon on average is 384,000 kilometers away from the Earth, which, to put that into context for you, is the same as going around our entire planet 7.5 times. And that's just one way. They've still got to come back again, and that is no easy feat. If anything, that is harder. And the journey would have been even more difficult if Michael Collins had to make it back alone. The bravery, determination and courage these three men shared was unparalleled, unmatched, but we're going to need plenty more humans like them in the near future, because the moon is just the beginning. This is how Mars may look in 50 years' time. Our plans to colonise the red planet are nothing new. In fact, when the Apollo missions ended, many people believed that in the next 50 years we would have colonised Mars. As you can probably tell, we are nowhere near reaching Mars, or at least a human setting foot on the red planet. We have sent many rovers there in attempts to analyse if it is suitable for us to live on. But as we know, Mars isn't very hospitable. The temperatures on Mars are a lot colder than they are here on Earth. There is much more carbon dioxide in the atmosphere. The gravity is less than half of that here on Earth, meaning it's not ideal. But we can make it habitable. We can change the composition of the atmosphere to make it a world in which we can live on. The trip to Mars is not an easy one. Going to the moon takes 2, maybe even 3 days to get there. But Mars, at its closest point to Earth, takes 8 months. And that is just one way. And I say that because it's likely that the trip to Mars will be just one way. It's very expensive to get there. It's even more expensive to come back. So those brave adventurers that are going to be the first people to walk on the surface of Mars will also die there. Perhaps that is the cost of exploration. That is the price you must pay to boldly go where no one has ever gone before. But if we create a world like this, in which they can live peacefully, carry out plenty of research which will be vital for future generations, then it will be well worth it. But arguably one of the biggest hurdles to overcome is chemistry between inhabitants. If you have an argument with one of your crewmates, you can't go outside and go for a long walk and just forget about the situation. You are going to be together for long periods of time in very close quarters, perhaps for the rest of your life, which can be very stressful. And the first people to go will be very expensive liabilities. It is no easy feat. There are plenty of missions being carried out here on Earth where they take isolated groups and put them together for years on end and see how well they fare in such close quarters with one another. Today it is a question of whether or not to send humans to Mars. We have the technology to do so, but there are still plenty of things holding us back. One thing is for certain though, and that is that the first person to walk on Mars is alive today. They may even be watching this video. To many of us, Mars is our best chance of finding life elsewhere in the solar system. Or at least it was. Out there, in the depths of our solar system, there are other worlds that may contain life. Not planets, moons. Moons that orbit around the gas giants. These are some of the most extraordinary worlds that we have ever discovered. And they hold plenty of potential for life. Do you see that moon just there? That is Io. It is the most volcanic world in our solar system. It is a hellish landscape, but even there may exist life. It makes up one of the 4 Galilean moons, all of which are potentially habitable. We could one day colonize those moons. We could live on them. Now this far out, the moons and the planet itself are very cold. They don't receive much heat from the sun. But how is it these moons are able to have the potential for life? Well, it's all due to their orbit around their planet. Rather than orbiting in a perfect circle, they move around in what is known as an eclipse, which is a slightly squashed circle. And it's because of this, there are points where they are closer and further away to their planet, which means they feel a stronger and weaker gravitational pull. This stress and tension on the core of the planet causes it to heat up. It's also why one of the other moons, Europa, is capable of harbouring more liquid water beneath its frozen surface than there is on all of Earth. One day we will go fishing on the surface of Europa, and we may indeed find life. There is potential for life beneath the frozen surface. It is isolated from the harsh environment of space. And Europa isn't the only frozen world in our solar system that's capable of supporting life. Orbiting around Saturn is a tiny moon known as Enceladus. It is responsible for Saturn's most outer ring. But because its gravity is so weak, it cannot hold on to the water. It immediately freezes as it leaves the geysers. It exits the atmosphere, meaning as Enceladus orbits around Saturn, it leaves a trail of these ice particles, and they produce Saturn's most outer ring, Saturn's E-ring. The geysers are proof that Enceladus has a warm core, and you can see at the south pole these tiger stripes. This is a very, very high potential for life elsewhere in our solar system. Beneath the frozen surface, life would be protected from the external environment of space. The very harsh vacuum and ultraviolet rays, none of that would affect life beneath the surface of this world. And as special as our solar system is, it is still just the beginning. There are plenty of other solar systems out there, each with a limitless potential for life. Some of which, though, will look very different to our own solar system. This is a more common sight than you may think. Two suns setting below the horizon is something that seems like it's straight out of science fiction. But a planet belonging to a star system that has two or more stars, a binary star system, is more common than singular star systems. Which means our star system is fairly unique. Our planet, its distance from the Sun varies very little during its orbit, perhaps 2 million kilometers. But if you were to orbit around two different suns, then your orbit would be chaotic. It wouldn't be as straightforward as going in a slightly squashed circle around your star. It would be chaos. It's likely that one star will be much larger than the other star. So your orbit will be based on the larger star, but also influenced ever so slightly by the smaller star. The temperatures between the two stars could also vary dramatically. One might be very hot, one might be very cold, which again means the temperatures that you feel on the surface of your planet would fluctuate rapidly. So where in our universe might there be stable conditions for life to thrive? Our Sun will die in 5 billion years. It's going to swell into a red giant as it reaches the end of its lifetime and possibly engulf our planet, burning it to a crisp, eliminating all forms of life on the surface. But there are stars out there that live for far longer than 10 billion years. Some that live for as long as trillions of years. These are red dwarfs, and they're amongst the most abundant stars in our universe. If they are a singular star system, like our Sun, then they have plenty of potential for life. One of the best chances for finding life outside of our solar system is in the TRAPPIST-1 star system. This is a star that contains plenty of candidates for life. This is the TRAPPIST-1 system. These are the planets that orbit around this tiny little star. And the reason this system is so special is because normally we find it very rare to see a planet orbiting around a star that exists in a habitable region, meaning it could potentially harbour life on its surface. But this system has several planets that exist in the Goldilocks zone, where it's not too hot and not too cold. And they're all very similar in size to the Earth, Venus, Mars and Mercury. Each one of these planets has the potential for life. The star system itself isn't very far away. You can see it in the constellation of Aquarius. It's about 40 light years from us. This ultra-cool red dwarf is barely larger than Jupiter, but it has a mass over 80 times that of the gas giant. Unfortunately, we have no way of viewing what these planets really look like. Planets do not emit light, so when we look out for these exoplanets, we have to analyse the light from their star. By monitoring its brightness, we can determine the size of a planet as well as its orbital period. We are also able to see the composition of a planet's atmosphere by measuring the spectroscopy of the light as it passes through the planet. We can then subtract this from the light's normal rays and determine whether or not it is capable of supporting life. In 2018, researchers determined that Planet E was the most likely out of all of the planets to be an Earth-like world. It could be covered in oceans of water, making it an excellent candidate for future habitation. Because of the star's small size and low temperatures, planets can afford to orbit a lot closer. This entire solar system would fit well within the orbit of Mercury. But being so close puts the planet at a high risk of being greatly affected by the radiation of solar eruptions. Because of the planet's close proximity to one another, if life were to develop on any one of them, it is extremely likely that it would spread to the others too. This means that there may exist life on not just one, but multiple worlds. This means that one day we will explore this system. There may be life awaiting on the surface for us. It may be advanced life that we one day communicate with. It may be simple life. This may one day become another home for our species. The technology to visit these new worlds is here today. We are capable of visiting the moon. We are able to visit Mars. We've even ventured to the very edge of our solar system. What we now need are individuals with the right amount of courage and determination and desire to explore. Individuals that enjoy these types of videos because they are interested in seeking the wonders out there. And when they do, they will make one big step for mankind. I'm Damon 𝐒𝐭𝐞𝐩, and this was Astronomical. How would you like to have your name spaghettified by a black hole in front of thousands of people at the end of every single episode? Well, now's your chance. Astronomical is produced just by me, which means the scripts, recording, editing, social media and costume design are all done by myself. And after the first 2 seasons, the budget is basically empty, which is why I'm now looking for donations towards the future of this science documentary. And they start at as little as £1. If you want to watch your name be annihilated by a star as it swells into a giant before going supernova, then you can do so for as little as £1. Or, if you'd like to watch your name be ripped apart into its individual atoms by a black hole in a process known as spaghettification, then you can do that for just £5. And then finally, for just £10, you can take your place amongst the stars where you belong, because anyone that donates to science is a superstar. There we are, and if you can't donate at all, that's completely fine. Just make sure you like and subscribe, because that also goes a very long way. Cheers.